We have spent multiple lessons discussing different quadratic equations, where you have like x squared minus 4x plus 3 equals 0. And we had to solve those different equations. And we had different methods for solving. We had factoring, we had completing the square, and we also have the quadratic formula. In this lesson, we're going to learn more about the graphs of these equations, and we're going to learn about a concept called the discriminant. So for example 1, here we have x squared plus 7x plus 10. If we use the quadratic formula to solve, my a value would be 1, my b value is 7, my c value is 10. If I plug it into the quadratic formula, we would have x equals the opposite of 7, plus or minus the square root of 7 squared, minus 4 times a, which is 1, times c, which is 10, all over 2 times a, which is 2 times 1. So we've done this before, and what I want to show you is at the end of the solving process. So we get 49 minus 40 inside of the radical, which would be 9. So we have negative 7 plus or minus the square root of 9 over 2. Well, the square root of 9 is 3, so we have negative 7 plus or minus 3 over 2, which would give me negative 7 plus 3 over 2, which would be negative 2, and negative 7 minus 3 over 2, which is negative 5. So I went kind of quickly through this because we've done this before, and I want to show you a few things about the graph of this equation. So this equation is set equal to 0. This is related to an equation where we have y equals x squared plus 7x plus 10. So instead of a 0, we have a y. All right, so if you have this equation right here, where it's y equals x squared plus 7x plus 10, we can graph this equation. All right, so when I graph this, we would get something that looks like this. And notice what we found. When we solve for x, it's negative 2 and negative 5. This is where it crosses the x-axis. Okay, so notice it crosses here at negative 2 and negative 5 on the x-axis. Those points are called the x-intercepts. So we would say the x-intercepts are negative 2 and negative 5. Another term we give to the x-intercept would be roots. So we can also say that it has 2 roots, which is the same thing as saying it has 2 x-intercepts. So the one root is at negative 5, 0, and the other root is at negative 2, 0. Now our objective in this lesson is to determine information about the roots or the intercepts based off just this initial equation right here. So to do that, what we want to do is look at this number right here, this 9. So the number inside of the radical. So this number right here tells us everything we need to know about the roots. So we see that it's not negative, right? So a square root of a positive number means it's going to be a real number. So we know that the roots or the intercepts will be real numbers. So because it's not negative, we have real roots. Also, it's a perfect square. So the square root of 9 is going to be a rational number, right? It's going to be 3. So because of that, we know our roots will be rational numbers. And then also, because this number is not 0, we know that there will be 2 roots. We have a plus or minus square root of 9, which would be a plus or minus 3, right? So we have a plus or minus number, which means we have 2 different answers, 2 different roots. And that number inside of the radical, that 9, is what we call the discriminant. So the discriminant tells us information about the roots. So our end objective is to not have to go through this entire process of solving with the quadratic formula or having to graph the equation to see what it looks like, but to look just at this number, at this discriminant, to determine the types of roots that we have. For example 2, we have x squared plus 6x plus 9 equals 0. And again, if I use the quadratic formula and I plug the numbers in, we plug a 1 in for a 6 in for b, and a 9 in for c. So when I do that, I would have x equals the opposite of b, which is the opposite of 6, plus or minus the square root of b squared, or 6 squared, minus 4 times a times c, or 4 times 1 times 9, all that over 2 times a, or 2 times 1. Now inside the radical, we have 36 minus 36, which would be 0. So we have negative 6 plus or minus 0, which would be negative 6. And then negative 6 over 2 is negative 3. So again, I went through this pretty quickly because our goal is to not have to need to do all of this. Our goal is to have to look just at this number right here, the 0. So looking at the graph, if we look at y equals x squared plus 6x plus 9, so replace the 0 with the y, and graph that equation, we would have this graph right here. Now notice where it crosses the x-axis. It crosses right here at negative 3, and that's the only place. So it has one root, has one x-intercept, which is at negative 3, 0. And that's what we see right here. We solve for x, that's how we found that point. Now again, our goal is to look at this discriminant, this number inside the radical, to determine what types of roots we have. So looking here, we see that it's not a negative number, which means our roots are going to be real roots. So it's not imaginary, it's going to be real. Now, 0 is a perfect square. So because of that, we know that our roots are going to be rational numbers. Okay, because the square root of 0 is a perfect square. And because this number is 0, we have a plus or minus 0, which is really the same thing. If you add 0 or subtract 0, that's the same answer, right? So because of that, there's only one answer, or one root. And we see that here in the graph. It's only crossing here at this one point. Let's look at another example. Here we have x squared plus 3x minus 6 equals 0. If we solve this equation by using the quadratic formula, we would have x equals the opposite of b, or opposite of 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a times c, or 4 times 1 times negative 6, all over 2 times a, or 2 times 1. So in the radical, we have 9, and then plus 24, which would give me a 33. So I have two different roots, negative 3 plus the square root of 33 over 2, and then negative 3 minus the square root of 33 over 2. And if we look at this initial equation and plug a y in place of 0, we have this related equation, which when we graph this, we would have the following graph. So notice where it crosses the x-axis. It's crossing between negative 4 and negative 5, and it's crossing between 1 and 2. The two roots are at negative 3 plus the square root of 33 over 2, comma 0, and then negative 3 minus the square root of 33 over 2, comma 0, which is approximately negative 4.372, 0, and 1.372, 0. So notice that based off this 33, we can tell very quickly that because it is not negative, our roots, or our x-intercepts, are going to be real numbers. So it has real roots, which means they exist. We know that they're there. Okay, but it's not a perfect square, which, because of that, we now have this really messy fraction and decimal. So because it's not a perfect square, it's irrational. The roots are irrational, meaning it's not going to be a whole number. It's got a decimal or a fraction. And then lastly, we know that because it's not 0, we have two roots. Okay, because we have a plus the square root of 33 and a minus the square root of 33. So we can tell all of this information just based off the number 33. Example 4, we have x squared minus 3x plus 4 equals 0. For this one again, if we were to solve using the quadratic formula, we would have x equals the opposite of negative 3, which is positive 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a times c, so 4 times 1 times 4, all over 2a, which is 2 times 1. So within the radical, negative 3 squared is 9, then minus 16 would give me a negative 7 inside of the radical. All right, so here we have two different roots, plus or minus the square root of negative 7. All right, so our related equation, if you took this and set it equal to y instead of equal to 0, and then we were to graph that equation, we would have this graph right here. So looking here, notice that it has no roots. It does not cross the x-axis. And we can tell that based off this negative 7. Because it is a negative number, we have a square root of a negative number, which is imaginary or not real. Which means, graphically speaking, that it does not cross the x-axis. It doesn't have actual roots. It does not cross. And because it's imaginary, it cannot be rational or irrational. And we do, because it's not 0, we would have two roots. So it has two answers, two roots, because we have a plus or minus the square root. So it has two answers or two roots, but they're not real, so it doesn't cross the x-axis. So again, our objective is to not need to go through this process, but simply look at this number right here to determine what type of roots that we have. So that's what we're going to do in the next few moments. We're going to just look at the number and try to answer what kind of roots we have. So for example, here we are told the discriminant is 0. And the first question is, how many roots or how many solutions do we have? Is it 0, 1, 2, or none of the above? Well, if the discriminant is 0, that means, if you think back in the quadratic formula, we have a plus or minus the square root of 0, because the discriminant is the number inside of the radical. So thinking of this, notice we have plus or minus 0, which is really the same thing, right? If you add 0 or subtract 0, it's the same thing. So because of that, we would have one solution. And then if you were asked, do we have real and rational solutions, real and irrational, or imaginary, we can determine again based off this plus or minus the square root of 0. So it's a not negative number, so we know that it cannot be imaginary. Okay, 0 is not going to make it imaginary. So it's got to be real, and the question is, will it be rational or irrational? Well, 0 is a perfect square, right? So if I take the square root of 0, I get 0. 0 is rational. Okay, it's not a decimal that goes on forever. So because of that, this would be real and rational. So just based off the number 0, we've determined that there's one solution and that our solutions are going to be real and rational. Now what if your discriminant were negative 3? Okay, how many solutions or how many roots would we have? Well, again, think of the quadratic formula and think of this negative 3 as being inside of the radical, because that's what the discriminant is. So looking here, we have a plus or minus a square root of negative 3. So we have positive or negative, which would make two solutions. The only time it's going to be one solution is if it's the square root of 0, because plus 0 and minus 0 is the same thing. So unless it's a 0, it's going to be two solutions in all those other cases. So two solutions, and then if we want to know if it's real and rational, real and irrational, or imaginary, we can begin by determining if it's real or imaginary. So notice the square root of a negative. Right here we have this would be an imaginary number, because anytime you take a square root of a negative number, it's going to be imaginary. So my answer, my roots are going to be imaginary, and we're going to have two answers or two different solutions. Now what if your discriminant were 4? How many solutions would we have? Again, think of this as being inside of the radical, because that is what the discriminant is. And notice we have a plus or minus, and this would be 2, right? Square root of 4 is 2. So we have two answers, positive 2 or negative 2. So we have two different roots. And then the next question is, what kind of roots? Well, it's going to be real because this number inside the radical is a number that's not negative, so it's got to be real. And it's a perfect square, which makes it rational as well. So my answer would be real and rational, and we'd have two different answers or two different roots. Now what about a discriminant of 15? So the first question is how many solutions or how many roots do we have? So for this one, we have a plus or minus the square root of 15. So here we have positive or negative, which means we have two different answers. So we have two roots, and then determining the kind of roots, we see that the 15 is positive, which means it's got to be real, so not imaginary. And the question now is it rational or irrational? Well, the square root of 15 is not a perfect square, which means it's going to be a decimal that keeps going forever, which makes it irrational. So my roots would be real and irrational, and I would have two different roots. All right, now what if we had to find this number by itself? Here we have an example where we are to find the value of the discriminant, giving x squared minus 4x minus 5 equaling 0. Now discriminant is just the part inside of the radical within the quadratic formula. And the quadratic formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now the discriminant is the part inside the radical, which would be this b squared minus 4ac. So to calculate this, I simply do b squared minus 4ac. This is my discriminant. So looking at the original equation, a would be 1. So a is 1. B would be this negative 4. And c would be the negative 5. So plug it into this discriminant. B squared is negative 4 squared minus 4 times a is 1, times c is negative 5. So that's going to give me 16, and then negative 4 times 1 is negative 4. Negative 4 times negative 5 is a positive 20. So 16 plus 20 gives me a discriminant of 36. And from here, if I wanted to, I can answer the questions we did in the previous slides. And I would see that we have two different solutions. So we have two solutions or two roots. And my roots would be real because a square root of a positive number is going to be real. And it's rational because it's a perfect square. The square root of 36 would be 6, which makes it rational. Let's take a look at one more example. Here we have 5t squared minus 4t plus 3 equals 0. And we're told to find the value of the discriminant. Now remember, the discriminant is the part inside of the radical within the quadratic formula, which is just the b squared minus 4ac. So here, a would be this 5 right here. B would be this negative 4. C would be 3. So we plug those numbers in. We now have negative 4 squared minus 4 times 5 times 3. Negative 4 squared is positive 16. And then 4 times 5 times 3 is 60. So I have 16 minus 60, which would equal a negative 44. So my discriminant is negative 44. And if I were asked what type of roots do I have, I can answer that we have two roots. I can answer that they would be imaginary because this is a negative number. And that is it. So we have two roots and it would be imaginary. And that concludes our lesson for today. We will see you next time.